Welcome to our instructional video on how to integrate the ECO 1150 interface box with the AegisTec Dry Contact Controller. Be advised that images and components in this video are used for illustrative purposes only. Handling high voltage wires from a breaker box requires electrical knowledge not provided in this video. All high voltage wire connections should be made by a licensed and qualified electrician. This video does not explain the safety requirements for making high voltage connections. Let's begin with an overview of the AegisTec Dry Contact Controller. This controller is specifically designed for users who aim to control AC assets. If your goal is to operate DC motors, please note that this is not the appropriate controller for that purpose. However, it's essential to remember that the AegisTec Dry Contact Controller itself operates on low-voltage DC power supplied by the external power supply provided with the unit. It is crucial not to attempt to run AC voltage directly into this controller. The AC voltage will only be present in the ECO 1150 interface box, which is designed to work in conjunction with the controller. Let's take a look inside the AegisTec Dry Contact Controller. The low-voltage DC power enters the controller from the external DC supply and is distributed to both the logic board and the top portion of the relay board. This power is used to engage the relays inside the controller. However, it's important to note that there is no voltage present at the terminals. The DC voltage necessary will be supplied from the ECO 1150 interface box. Let's focus on the lower board located on the door of the AegisTec Dry Contact Controller. This board is also known as the relay board. It features 10 terminals that function as dry contacts. These terminals are considered dry contacts because the controller does not supply any voltage to them directly. Instead, the DC voltage needs to be provided by the ECO 1150 interface box. When the voltage is present and a relay engages, it will close the circuit, allowing the DC voltage to be sent back out to the ECO 1150 interface box. We will now move on to consider the ECO 1150 interface box. This interface box is specifically designed for controlling up to 8 AC assets. Please note, if your goal is to control an AC motor, this is not the appropriate unit. You would need an AC motor box. An AC motor box is specifically designed to shut off the contactor when the motor transitions from open to close. The ECO 1150 features 8 contactors, each capable of handling 120 volts AC. 2 contactors can be paired together to handle 240 volts AC. With this setup, the box can either control 8 fans at 120 volts or 4 fans at 240 volts. Advancing Alternatives also offers a similar product, the ECO 1100. The ECO 1100 is essentially the same as the ECO 1150, but with a key difference. It features only 4 contactors. The wiring instructions provided in this video can also be applied to the ECO 1100 when it is paired with an AegisTec Dry Contact Controller. Before we delve into the process of wiring AC fans to the contactors in the ECO 1150, let's first discuss the signal wire that comes from the AegisTec Dry Contact Controller. We will now focus on the specific area of the ECO 1150 where the signal wire will be connected. This is where the signal wire from the AegisTec Dry Contact Controller will interface with the ECO 1150. In the image, you'll notice variously colored wires. These correspond to the output terminals in the AegisTec Dry Contact Controller. Let's display side-by-side images of the signal wire inside the ECO 1150 and the signal wire inside the AegisTec Dry Contact Controller. On the left, you'll see the signal wire inside the ECO 1150, and on the right, you'll see the signal wire inside the AegisTec Dry Contact Controller. Let's start with the 24-volt DC signal that comes from the ECO 1150. This voltage is sent via the green wire and the black wire on the left. These wires will connect to the top, or normally open, bus bar inside the AegisTec Dry Contact Controller. As long as the bus bar is intact, it will provide DC voltage for all the terminals below. These wires will bring DC voltage into the lower portion of the relay board. When a relay engages, the signal voltage will be sent back out via the wires connected to the output terminals. In this case, you'll notice that terminals 1 through 4 each have one wire, corresponding to A1, A2, A3, and A4 in the ECO 1150. However, you'll notice that output terminals 5 and 6 each have 2 signal wires. These correspond to B1 and B2, and B3 and B4, respectively, in the ECO 1150. This setup is due to a current programming limitation of the AegisTec which allows for a maximum of 6 fans to be listed on the touchscreen. In this configuration, when Fan 5 turns on via the AegisTec Plus touchscreen, it will cause 2 fans to engage in the greenhouse, specifically the ones wired to B1 and B2 inside the ECO 1150. Now that we have successfully connected the signal wires between the ECO 1150 and the AegisTec Plus Dry Contact Controller, let's proceed to the next step, wiring the fans into the ECO 1150. Please remember that all high-voltage wire connections should be made by a licensed and qualified electrician. This video is for informational purposes only. An electrician will wire the 3 wires coming from a 110-volt AC fan as follows. The ground wire will be connected to the breaker box. The hot wire and the neutral wire will be wired into the ECO 1150, as shown in the illustration, where we are connecting this fan to run off the A1 contactor. The hot wire will be connected to the terminal marked line, and then another hot wire will be run from the other line terminal to the breaker box. The neutral wire can either be wired directly to the breaker box or, as shown in the illustration, it can be wired into the ECO 1150 and then connected to the breaker box. Let's now discuss how to wire a 240-volt AC fan. This setup requires 2 contactors. In the illustration, we'll be using contactors A1 and A2. The ground wire will be connected to the breaker box. The hot wires will go into the line terminal for the 2 paired contactors and then back out to the breaker box. Finally, when wiring a 240-volt fan, it's crucial to ensure that the signal wire coming into the ECO 1150 is jumped to the signal terminal for the second contactor. For instance, in this image, the signal wire coming into A1 must be jumped to A2. This step is necessary to ensure both contactors work in unison when the fan is activated or deactivated. Thank you for choosing Advancing Alternatives. More information and additional resources can be found at advancingalternatives.com/knowledge center.